In this next section, we're going to look at polynomials and factors, and specifically how to factor polynomials, but also how to do the reverse and take factors and make it into a polynomial. So in problem number 1, we're asked, what is the factored form of x cubed minus 2x squared minus 15x? As you've been previously told, the first thing you should do is look for a GCF. So when we look at each of those terms, we can see that we've got 3 x's in the first term, 2 x's in the second term, and 1 x in the third term, which means we can take 1 x out of that entire polynomial equation or polynomial expression. This is going to leave us with x times x squared minus 2x minus 15. At this point, we would look for any more GCF, which there isn't any. We would look into if this is a perfect square trinomial, which it's not. It's definitely not difference of squares, so that's going to leave us with regular old factoring. When we do our regular old factoring, we get x times x minus 5 times x plus 3. In problem 2, we're asked to find the zeros of a polynomial function. So remember that anytime it asks for zeros, we can interpret that in one of several different ways. Zeros can also be called roots, they can be called solutions, answers, x's, x-intercepts. Basically, what is the value of x? That's what we're looking for. So we're given y equals x plus 2 times x minus 1 times x minus 3. So take each one of those individual factors and set them equal to 0 using the zero product property. So x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. Then just solve for x. So subtract or add according to what you need to do. And we're left with x equals negative 2, x equals 1, and x equals 3. So the next part of this question is to graph the function. So what you want to do is go ahead and put your x-intercepts on the x-axis. So you'll have points at negative 2, at 1, and at 3. So now we need some other points to figure out kind of what the graph looks like, the shape of the graph. So choose negative 1, 0, and 2. When we plug those numbers into the factors that we're given, what we'll end up with is that for negative 1, we get 8. For 0, we get 6. And for 2, we get negative 4. So we'll plug those onto the coordinate plane and then draw the cubic function in, or the cubic graph in between there, and that's what you end up with. For questions 3a and 3b, we're going to reverse the process. This time we're asked, what is a cubic polynomial function in standard form with zeros negative 2, 2, and 3? So we know that we're going to end up with something that looks like y equals x cubed. What we want to do is we want to identify what are our x's. So again, x equals negative 2, 2, and 3. Now take those and put them into factored form. Remember that factored form is of the form parentheses x minus a. So we're actually going to reverse the sign of whatever the x's are. So when we plug negative 2 into our factor, we get x plus 2. When we plug positive 2 into our factor, we get x minus 2. And when we plug positive 3 into our factor, we get x minus 3. We're then going to FOIL this out. So the easier pair to start with is the x plus 2 times the x minus 2, which gives you x squared minus 4. Then you FOIL out the x squared minus 4 times the x minus 3, and that's going to leave you with y equals x cubed minus 3x squared minus 4x plus 12. Make sure it's in standard form, and then you're done. That is your cubic polynomial. In 3b, we're going to do the same process, but this time it's for a quartic polynomial. And the zeros are negative 2, negative 2, 2, and 3. So again, write out your zeros and then put them into factored form. So x plus 2 times x plus 2 times x minus 2 times x minus 3. And you can see that what I've done is I've reversed, or I've exchanged the places of one of the x minus 2's with the x plus 2. And what this allows me to do is to basically FOIL out a difference of squares, which is going to leave me with 2 terms. If I had done x plus 2 times x plus 2 and just kept the same order, I would end up with 3 terms inside of those parentheses. And the process becomes just a little bit more complicated. By doing this, I can keep it a little less complicated. I also did the x plus 2 times the x minus 3 at the same time. So on the next line, you can see that I've got x squared minus 4 times x squared minus x minus 6. Now I'm going to distribute both the x squared and the negative 4 to all three terms in the second set of parentheses. When I do that, I'm left with x to the 4th minus x cubed minus 6x squared minus 4x squared minus 4x plus 24. So combine any like terms that you have, and then you'll end up with a quartic polynomial of x to the 4th minus x to the 3rd minus 10x squared minus 4x plus 24. And for problem number 4, we're going to reverse the process yet again and go back to being given the expression or the equation and then finding out what are the x's. So this time we're asked what is the factored form of x to the 4th minus 2x cubed minus 8x squared. Now I'm going to continue it on to finding the zeros. So we've got x to the 4th minus 2x cubed minus 8x squared. Again, start with looking for a GCF. In this case, we've got 4 x's, 3 x's, and 2 x's. So we can pull out an x squared from that expression. When you pull the x squared out, you're left with x squared minus 2x minus 8. Now remember, keep that x squared on the outside because that is going to be actually 2 of our solutions. Once you've got that done, then you can factor the x squared minus the 2x minus 8, and you'll be left with x squared times x minus 4 times x plus 2. Now what you'll do is you'll take each one of those factors and you're going to set it equal to 0. Using the zero product property. So x squared equals 0, x minus 4 equals 0, and x plus 2 equals 0. Now the x minus 4 and the x plus 2 are pretty easy. You're just going to get x equals 4 and x equals negative 2. With the x squared, we have to take the square root in order to isolate the x. Now, since we've got an exponent of 2, what this tells us is that we're going to have 2 zeros are going to be answers. Now, this is also going to make sense because look at how many answers we'd have. We'd have 2 zeros, a 4, and a negative 2. So you're going to have 4 solutions to this problem. Well, what was your original exponent? The original exponent or lead exponent was a 4. So your lead exponent is always going to match the number of answers that you arrive at.